Now we're going to explore roots again using the radical symbol, what most people think of when dealing with roots. So let's first understand this symbol. You read this as nth root. And it's important the n here is sort of buried in this crevice, okay? Alright, so that's called nth root. If you have a 2 where the n is, bury your 2 inside that crevice, you can call that second root. That's actually not as common of a name as square root, but it could be called a second root or square root. And this one is the most common. So writing that number, which is called the index, by the way, that's in this crevice, gets to be a hassle. A lot of people forget to write it, actually. So this is the most common root. So we usually write just this radical symbol with no index, and that means square root. So this is a hidden 2. If there's nothing there, it's a 2. Okay? And of course, we could keep going with this list. If there's a 3, you probably can guess it's called a third root, or most commonly called a cube root. And we'll do one more. If there's a 4 there, it's simply called a fourth root. It's not. A lot of people mistake this and say the fourth square root. Okay? That is not at all what it says. That's wrong. Fourth root. This symbol, this radical symbol is what it's called, just means root. That's it. Now, the radical symbol here is still root, but if you don't write a number there, it's a square root. If there's a different number, it's that type of root. Okay, so make sure you understand that. Okay, so we've already said it. This thing is the radical symbol. And what it means, we'll look at it shortly. We've already, in another video, I discussed roots. So this does mean roots, but what it indicates is it's going to give one answer, not two. It's going to give one answer if possible. Regardless of the type of root, regardless of the index. It could be a square root, cube root, fourth root, fifth root, no matter what, it's going to give one answer. It will not give more than one answer. So that's the key to this video, is starting to understand that that's consistent no matter what type of root you're looking at here. This symbol always means one answer. Okay? Alright, so let's talk about a problem that this creates for us. Since even roots often give two answers, one positive and one negative, we have to choose which one the radical symbol will give, because it can only give one of those answers. Okay, so that's the dilemma here. And that's what we're trying to decide. So let me give you an example of what I mean by this. So we know 9 has 2 square roots, 3 and -3. So if I write this, if I use the radical symbol to indicate my square root, what does it equal? Does the square root of 9 equal to 3 or the -3? Because we know 9 has 2 square roots. And what we're going to say is it's agreed upon by mathematicians that the square root of 9 with the radical symbol will give us the answer of 3. Okay? And so why is that? Hopefully that's the answer you would have chosen as well. Even roots, or even root radicals, give only the positive answer. Okay, so that's important. Give only the positive, let's say, root answer. Even though even roots have two answers, the symbol tells us that we're going to choose the positive answer. Okay, so when the symbol is used, we give the positive answers. Also, when the radical symbol is used with even roots, we give it a special name. It is called the principal or positive root. So you might see that term, the principal root. When it says the principal root, it means the positive root. All right. So that's good to know as well. Now let's go do a bunch of examples. First, understand odd roots always give one answer. So there's no dilemma with odd roots, right? The dilemma is only with even roots. If you have an even root with a radical, you give the positive answer only. If you have an odd root with a radical, you give the one and only answer. Okay? Number 1, the square root of 16. Since we're using the symbol, I could call this the principal square root of 16. Well, that's 4. 16 has two square roots, but because I'm using the symbol, I'm only going to give my positive 4 as my answer. Number 2, the square root of negative 16. Well, we already know there's no real number that multiplies by itself twice to be negative 16. So this is not a real number. So here's a case where it doesn't give an answer at all. So the point is the symbol will never give more than one answer. Sometimes it won't give an answer. Okay? It could give 0 answers. Number 3, what if the negative's outside of the square root? Well, the way to think about that is this is the negative square root of 16. So what you do is you consider this as being its own individual, and you carry down the negative outside. So you've got your negative, and then this is the positive square root of 16. So this guy right here in yellow is the positive square root of 16. So you just take the positive square root of 16, which is 4. So you've got negative 4. Okay, it's different than example 2. Example 4. In example 4, let's look at the cube root of negative 125. We're trying to find one answer, if possible, that will multiply by itself 3 times to be negative 125. Well, that's negative 5, not positive 5. Negative 5 times negative 5 times negative 5 is negative 125, so that's our answer. And you can see the cube root gave one answer, as we expect for any odd root. Alright, example 5. Let's look at the fourth root of 16. This is an even root. We know that 16 has two fourth roots, right? 2 times 2 times 2 times 2 is 16, and negative 2 times negative 2 times negative 2 times negative 2 is 16. So the answer here is going to be the positive root, because I'm using the radical symbol. So the positive 2 is my fourth root of 16. Okay, number 6, the fourth root of negative 16. What times itself 4 times will be negative 16, and because that's negative, you can't multiply anything by itself 4 times to get a negative, so this is not a real number. Number 7. This one's missed a lot. What about the square root of 0? What times itself 2 times equals 0? Well, the answer is 0. A lot of people think you can't take the square root of 0. Well, 0 times itself 2 times does in fact equal 0. So yes, 0 is the square root of 0. Number 8. The square root of 36 x to the 6th. We're trying to think what multiplies by itself 2 times to be 36x to the 6th. Well, 6 times 6 is 36, and x to the 3rd times x to the 3rd is x to the 6th. Now, You might think that this is positive. Remember, this symbol means as it's applied to an even root, this is a square root, we need a positive answer. The problem is x is an unknown number, meaning that this answer could be negative. So what we do is there's a very simple way to make something positive without changing its value. Let me erase this circle here. And the way to do that is just to put the absolute value bars around it. Now we have 6x cubed, but it's positive no matter what x is. Okay, absolute values turn things into positives. And so I like this answer. There are other ways you could write this. Textbooks might go further in the way they write it, but this is very simple. I'd rather leave it like this. Okay. All right, example 9. Example 9, I've got the negative fifth root. Notice how I'm burying my index, my 5, inside this crevice. Negative fifth root of x to the 20th. So what do? I carry my negative down, and I evaluate the fifth root of x to the 20th. So what times itself 5 times equals x to the 20th? Well, the answer is x to the 4th. So this is x to the 4th, carry my negative down, and my answer is negative x to the 4th. Example 10. The fourth root of 81 x to the 12th y to the 16th. I want to point out one more thing about the radical symbol. I've already said you should always nestle your index inside the crevice here in the front. You should also make sure that the top of your radical is long enough to cover everything underneath. For example, if my radical symbol stopped short, it would not be clear if the y to the 16th is multiplied by the radical on the outside or if it's multiplied by the stuff on the inside of the radical. So you need to be very clear about that. Alright, so here we're trying to figure out what will multiply by itself 4 times to be this. I know that 3 times itself 4 times is 81. X to the third times itself 4 times is x to the 12th. And y to the 4th times itself 4 times is y to the 16th. Since this is an even root, I have to make sure my answer is positive, so I just put absolute values around it. Now, let me show you why this is the answer. If I take 3x to the third times y to the 4th, that whole thing times itself 4 times. Hopefully you can see that you do in fact get 81 x to the 12th y to the 16th. Okay, so since it's all multiplication, that's why you can multiply your 3's, your x cubes, and your y to the 4ths all separately. You can multiply these in any order because it's all multiplication. Alright, let's do one, maybe two more examples. Number 11, the cube root of the fraction 27/8. So I'm thinking of a fraction that will multiply by itself 3 times to be 27/8, and the answer is 3 halves, because 3 halves times 3 halves times 3 halves equals 27/8. Alright, our last example, the fifth root of negative 32 x to the 15th. So something times itself 5 times to equal negative 32. Well, that's negative 2, because you can multiply it by itself 5 times to get negative 32, and then you need x to the third would multiply by itself 5 times to get x to the 15th. So there's our cube root. It's an odd root. I don't need my answer to be positive. I just need it to be the answer that I get, and that is the answer that I get. So here are several examples showing you how to think about the radical symbol and roots, and whether the answer should be positive or not, whether the answer should even be a real number or not.